Hello everyone, welcome to the coding portion of my presentation. I would like to walk you through my code that I used to model a image recognition machine learning model. And to start us off, I would like to talk about the libraries I used. I used FastAI. The most common library for image recognition classifiers, and the standard data science libraries such as Pandas, NumPy, and Matplotlib. So for this project, I needed large amounts of images to train my model with. So the premise of this project is to identify images of plant diseases, specifically hydroponic plant diseases. So all I did was I Googled hydroponics plant diseases and used the 10 most common plant diseases and Googled them and went to Google Images. So, for example, powdery mildew is one of them. And I used a Chrome extension to download all those images to my hard drive and then uploaded them to Google Drive. And in this Google Colab notebook, I imported all those images through a drive mount and saved that project path. Then I normalized all those images and saved it to a data variable called data. And to look at those data classes, I just ran this code and it shows us nine different all the nine different plant diseases that are very common in hydroponics. And I created all those files in a project folder and uploaded all the images that I downloaded from Google into these folders. So if I wanted to look at an example of those images, um, you can see here that it matches those diseases well, and the upload was successful. And then if I wanted to look at a few more details of those data classes, it's 9 different folders and 9 different kinds of diseases. And we have a total of 513 images to train this model with. The FastAI library is extremely compact, which means I only need one line of code to train the model, and I decided to run it with 8 cycles. And I ended up with 68% success rate and an error rate of 32%, which is very good considering the noise in the data. If you look at these images, there are a lot of images that don't actually exemplify the disease in question. For example, powdery mildew. This is really hard for any image classifier to recognize and to train the model with. And some images also have other kinds of diseases in them. So I was pretty happy with these results, and I still wanted to improve the model. So I looked at the learning rate plot, and it plots the learning rate with the loss rate. And in order to improve the model, I wanted to find the steepest descent of the loss rate. Um, it actually doesn't have many steep descents, so I tried to plug the steepest descents in, but my error rate didn't actually decrease. So I decided to stick with the first model, and I took a look at the confusion matrix to see which variables, so which diseases actually were confused most commonly with other diseases. So if you take a look at the diagonal boxes here, those are the correctly identified plant diseases. and all the other boxes are the incorrectly identified plant diseases. And the great thing about the confusion matrix is that you can see which were the most common confusions. So if you take a look at the highest numbers outside of the diagonal, number 5 is powdery mildew and downy mildew. And if I Google those two really quick, I look at downy mildew, you can see that they're very commonly confused with each other because they actually look very similar. And another example would be white flies and aphids. They both are small white flies, so it comes to no surprise that those might be easily confused. And if I wanted to take a look at some images that have been confused and misclassified, whiteflies and thrips is one example, and if you look at those two flies and pictures of those, they're actually looking very similar. And if I wanted to, for example, run a few images that I didn't use to train the model and see if the model correctly identifies those, um, I went ahead and Googled a few of those diseases and used some pictures that I haven't used to train the model with. And so that's what we're going to do right now. I'm going to uncomment this and take a look at another image of powdery mildew that hasn't been used to train the model with. And I'm going to see if the machine learning model actually correctly identifies powdery mildew here. And it says it's category number 4. And if we look at our list, category number 4 is 0, 1, 2, 3, 4, and it says powdery mildew, and it correctly identified powdery mildew here. Let's do it with one more. Uncomment this to take a look at it. So these are spider mites, and you can see them in a web on a plant here. And we're going to take a look if it correctly identifies those spider mites. These might be a little more difficult because there's more noise in the picture. But it says number 6 in the list, and if we go back, it's a list of 8, and it says spider mites. So it did indeed correctly identify those two examples. Going back to the bigger picture, the goal of this model is to continuously improve. So if this rolls out as a service for agroponics, you can actually use the images that the user sends to further improve the model and decrease the error rate and actually make the service better. Anyways, thanks for watching, and please make sure to read my project description, and if you haven't already, look at my first video that describes the big picture of the project. Thank you.